Welcome to this video lecture on the subject basic electrical and electronic circuits. So in this lecture we are going to discuss about tunnel diode. So it is a type of semiconductor device. So normally we have a PN junction diode, Zener diode. So in semiconductor devices, coming to special semiconductor devices which are used in high frequency operations, one of the diode is tunnel diode. So we are going to discuss about the constructions and the characteristics and applications of tunnel diode in this lecture. So first of all, let's discuss what is the need for tunnel diodes. So when conventional diodes are very slow at high frequency circuits, there is a requirement for microwave and high speed circuits in which special semiconductor diodes are used. For example, tunnel diode consists of a thin depletion layer which works based on the quantum mechanical tunneling. So these diodes are used in microwave and high speed circuits. And what is meant by tunnel diode? So it consists of an anode and cathode in which it works on the principle of tunneling effect. And also the important property is negative resistance. So these two makes this tunnel diode as a high speed switch, and also it is used in radar and communication systems. So it is a heavily doped PN junction diode. What is the construction of tunnel diode? So construction here, heavily doped P region and heavily doped N region are given in this diagram. So like this, very thin depletion region is formed in this diode. So due to the depletion layer thickness of very less, approximately 10 nanometer, so the electrons can be easily cross the barrier. So this is known as the electron tunneling. And principle of tunnel diode. So tunnel diode working process is given. Based on the quantum tunneling, electrons pass through the barrier without the enough energy. So this happens due to the thin depletion layer present in this tunnel diode. So this produces the effect called as negative resistance, which means at a particular voltage called as the peak voltage, the current attains maximum and then the current drops to the minimum value. So this is given in this characteristics of tunnel diode, where in forward bias region peak current is given, and after this peak point the current decreases. So this effect is known as negative resistance. So the negative resistance region is marked from peak point to valley point. So here increasing the voltage gives the decrease in current, so which does not have in PN junction diode. So this is the special property of tunnel diode. By using this property, we can use it in oscillators and amplifiers. So it enables oscillations, amplifications, so which are useful in RF and microwave circuits, so especially in high frequency circuits. So for example, it increases the signal strength in amplifiers. By using negative resistance principle, RF amplifiers can be constructed, and RF circuits are essential for high frequencies. And oscillators, which generates the continuous signal, so it is used as an RF and microwave frequency oscillator. So this voltage increase causes the current to decrease. So this property is applied in various areas of RF and microwave circuits. And let's see the advantages and applications of this tunnel diode. So here it is a high speed device, and also it works at high frequencies, which is suitable for microwave range of frequencies. So it is very essential for generating the oscillations at high frequencies, and also it enables the unique circuit design because of this negative resistance property, and it consumes low power, which gives energy efficiency, and also it gives a small size considered for a space constrained devices. And let's see the applications of tunnel diode. So it is used in microwave oscillators and high frequency amplifiers and fast switching circuits, radar and communication systems. Let's take the assessment questions. The negative resistance property of tunnel diode is caused by high temperature, heavy doping and quantum mechanical tunneling, avalanche breakdown, ionic conduction. So the answer is B, heavy doping and quantum mechanical tunneling, which is the property of a tunnel diode. And second one, tunnel diode is most commonly fabricated from germanium or gallium arsenide, pure silicon, carbon nanotubes, lead acid. So the answer is A, germanium or gallium arsenide, because these are the special elements. So like PN junction diode, silicon or germanium cannot be used for these special devices. So germanium or gallium arsenide are used for tunnel diodes. So thank you for listening this lecture.